Welcome to The Debate. Today, we're digging into Meta's big push into spatial computing. Specifically, they've dropped two key pieces of hardware, the Ray-Ban Meta display glasses and this new Neural EMG Wristband.
Right. And the source material really pushes us to ask, what's the real defining component here? Is it the glasses, the advanced wearable display, or is it this, frankly, revolutionary neural input system? Which one truly marks the new frontier?
And I'll be arguing that it's the glasses, the Ray-Ban Meta display glasses. They're highly integrated, they're functional, they're actually ready for users now. I think they're the necessary foundation, solving huge barriers and really setting the standard for what wearable spatial computing needs to be.
See, I come at it a bit differently. The glasses, yeah, they give you the window, you need that. But I'm going to argue that the Neural EMG Wristband, this fundamentally new way for humans and computers to interact, that's the real intellectual leap. History shows these frontiers are often defined by how we talk to machines. And I think this EMG system is the true long-term game changer here.
Okay, but the frontier has to be defined by what people are actually, willing to wear every single day. The functional integration of all this digital power into a form factor that's socially acceptable, basically, stylish sunglasses. That's what makes the whole vision even viable. I mean, if you look back at why things like earlier AR glasses, our heads-up displays failed to catch on, it was almost always the bulky design, right? Terrible battery life, displays you couldn't even see outside.
Okay, fair point on adoption hurdles.
Exactly. And these Ray-Ban Meta glasses, they seem to have actually overcome a lot of that with some pretty impressive technical fidelity. We're talking about real functionality packed into these light frames, taking, 46 megapixel photos, streaming audio with directional speakers so others don't hear it easily, and crucially displaying information with a 600 by 600 pixel resolution in one lens. And I want to pause on those specs for a second, because they really explain why it's the frontier. That display, it hits a peak brightness of 5,000 nits. Now, for anyone not deep in display tech, that kind of brightness is, it's essential. It basically solves that age-old problem of AR glasses being useless the second you step outdoors into sunlight. If you don't solve visibility, the whole system just collapses, right? So this device, it is the platform for spatial computing because it proved that you can have daily, integrated, usable computing outside of a controlled lab environment.
That's a fair point on the history of output display, definitely. But I think you might be confusing the successful commercialization of a, let's say, form factor with the fundamental innovation that's driving the conceptual leap forward. Yes, okay, the glasses are necessary to see the digital world. But the history of computing, it just screams that paradigm shifts are defined by input.
But is that always true for spatial computing?
Well, think about it. The move from command lines to GUIs, right? Or from keyboards to multi-touch screens. Those weren't just display updates. They were revolutionary new ways of communicating our intent to the machine. And this EMG wristband, it introduces that next major conceptual shift. We're moving beyond deliberate, kind of large physical actions.
Okay.
So, just to be clear, this Neural EMG wristband, it reads electromyography signals, tiny electrical impulses from your wrist muscles. It can detect them before you even fully make the movement. So the system can interpret these really subtle, almost subconscious intentions. I mean, that is the definition of a leap in human-computer interaction. HCI.
Right.
And the wristband allows for incredibly subtle finger gestures to replace what are usually clumsy controls. We're talking tiny movements like a gentle tap of the thumb and forefinger means select, tap thumb and middle finger means back. It's not like waving your arm around like some old Wii remote, It's more like having an invisible mouse button right there in your hand. The potential here is, it's visionary. Handling gestural navigation, maybe even writing in the air and having it transcribed directly to text. That completely redefines the interface itself.
I respect the technical assessment there, I really do. But I think you're celebrating a technical concept that's kind of functionally inert with the huge engineering success of the glasses themselves. We need to define what the foundational leap in spatial computing specifically is. And spatial computing, by its very nature, it requires spatial output. It needs that information overlay onto the world.
Well, yes, it needs output, but...
Look, The EMG wristband, no matter how revolutionary the biosignal processing might be, it's still fundamentally a sophisticated input device. If those glasses weren't high-spec, high-fidelity wearables that could actually show you calendar alerts, music playback, live messages with, again, 5,000 nits of brightness so you can see it outside, those subtle input gestures would be completely pointless, wouldn't they? The glasses create the visible environment where that input actually has meaning. The true frontier is established where that seamless, functional digital information meets the physical world in a way that's usable, durable, and critically visible. The glasses solve the problem of presence. The wristband just offers a clever way to navigate within that presence.
But the history of computing proves that the conceptual control mechanism is the most profound advancement. You're focusing on display resolution, brightness. These are really just iterative improvements on existing output tech. The wristband fundamentally redefines the relationship between human intent and machine execution. It moves us closer to this, like, frictionless, almost neural-based interaction. That shift feels much more foundational than just updating display specs, however impressive the miniaturization is.
Okay, but
And furthermore, let's talk about the technical difficulty here. You mentioned the 5,000 nits of brightness challenge. Okay, I raised the latency challenge. That EMG system has to read those incredibly faint electrical signals, filter out all the noise, interpret them using machine learning models trained specifically for each user's unique muscle patterns, and then translate that into a command, all in near real time. We're talking milliseconds. That low latency biosignal processing, that seems like a far greater technical barrier and thus a bigger innovation than figuring out how to pack existing display panels into a smaller frame.
That's an excellent point about the latency and the personalized machine learning models. I absolutely acknowledge that's a significant technical achievement. But let me push back a bit on this question of readiness and utility versus just, raw potential.
Okay.
For a new frontier to actually launch, it needs to achieve immediate, tangible utility, something that drives commercial adoption. For someone to shell out, $799? They need to see the immediate benefit. Calendar alerts, music, good photos, all packed into sunglasses they might actually want to wear. That utility is what gets the platform off the ground. The glasses provided the necessary vehicle for Meta to even attempt shifting computing from fixed screens to daily wear. And that success feels immediate, tangible.
Right. The commercial aspect.
But wait, think about it. If the wristband is the real technological core, the long-term future as you suggest, why did Meta launch the glasses first? Doesn't that sort of imply that the display and the form factor were the biggest, most pressing blockers right now, and therefore they represent the essential foundational leap that had to be made first?
I understand the commercial necessity, I really do. But that necessity doesn't automatically define the innovation. You're absolutely right. The glasses are the commercial Trojan horse, right? Designed to solve the immediate adoption problem by disguising a computer as a fashion item. However, the source material itself pointed out the, quote, early stage awkwardness and glitchy nature of the whole hardware system working together.
It did mention that.
Which suggests, to me at least, that the current display iteration in these glasses, it's probably temporary. It's like an early prototype of the visual output. The revolutionary foundation, the EMG input system, that's what's going to mature over the next, say, decade. The wristband's success is conceptually independent of whatever display limitations the current glasses have. It defines the future interface, whereas the current glasses just define the current display tech. We have to separate the necessary sales mechanism from the defining conceptual breakthrough.
I find that distinction between sales mechanism and conceptual breakthrough a little unconvincing, mainly because in spatial computing, the output mechanism dictates the entire interaction space. If the visual experience is poor or clunky, no amount of subtle, cool input can really redeem the system, can it?
Let's go back to the technical feat of the glasses for a second. You seem to minimize the miniaturization challenge. Think about all the components they squeezed in there.
High-res camera, speakers, the display itself, all fitted into lightweight frames that also have to maintain privacy. That low light leakage, around 2%, is actually crucial for social acceptance and high visibility. This isn't just cramming existing tech into a smaller box, it's inventing new ways for thermal management, power distribution, component density, stuff that previous generations of hardware just couldn't pull off. This level of technical miniaturization, that's the primary technological feat needed to make spatial computing truly wearable, and therefore viable.
Okay, but I think the biggest constraint on viability might actually be the system complexity you're effectively advocating for by prioritizing the current setup. Let's elaborate on that dependency. The system right now needs two separate pieces of advanced hardware, glasses and wristband, plus you still need your smartphone tethered for connectivity. That inherent complexity limits adoption, and it kind of defines the glasses, at this stage anyway, as merely a display shell for what seems like a superior input system. I mean, if the input is so intuitive and groundbreaking, why does it need two extra devices just to function fully? The subtle gestures are meant to feel natural, yet they require this external, highly complex processor, the wristband, to even work. That contrasts pretty sharply with previous foundational leaps, doesn't it? The mouse was self-contained, the touchscreen was self-contained. This dependency on a separate, dedicated neural interface kind of suggests that the input is the revolutionary engine and the glasses are just, for now, tethered to it.
Well, that tethering is temporary, surely. It's a necessary step right now to overcome power and processing limits. But let's focus on the form factor again. You argue the two-piece system is a limitation, but I'd argue that the successful integration of all the output components into just the glasses is the prerequisite breakthrough.
Okay.
If the glasses were still bulky or had a terrible display, that revolutionary input would have no appealing interface to control. The glasses solved the critical physical integration problem. They made a functional computer feel like an accessory people might actually choose to wear. That's where the frontier gets established. They took the tech from the sort of clumsy realm of, say, Google Glass, and pushed it towards something potentially desired for daily wear. That engineering accomplishment, overcoming the barriers of social acceptance and technical density, that's the necessary condition for this whole ecosystem to even exist.
I agree, form factor is absolutely crucial for market entry, no question. But if the display is ultimately just a very high-spec, high-fidelity window, then the truly disruptive technology, the thing that changes the game, remains the input. The EMG wristband introduces a level of intuition that fundamentally changes how we interact with digital space. It's moving beyond tapping screens or, shouting voice commands. It's heading into the realm of controlling the digital world with what are essentially subconscious muscle cues. When we look back maybe in 20 years, I suspect we'll remember the glasses as the device that finally made AR palatable, maybe even fashionable, but we'll remember the EMG wristband as the device that fundamentally changed the relationship between humans and computers. The wristband lets you sort of sculpt reality with faint intentions. I mean, that's pure science fiction starting to become real.
So to summarize my position then, without a compelling, high-fidelity, and practical wearable display platform, which is the glasses, this whole spatial computing frontier simply cannot be established. The glasses solve the hardest engineering problems related to viability, desirability, wearability, setting the stage for everything that follows. They are the functional cornerstone of this new epoch.
And while I absolutely acknowledge the profound engineering feat represented by the glasses, the miniaturization, the market readiness, all of it, the conceptual leap, the thing that redefines the paradigm, is rooted in the wristband. History shows us that conceptual leaps in control are what define the major shifts in computing. And the EMG system is poised to redefine interaction with digital environments far beyond simple touchscreens, far beyond even voice commands. The wristband defines how we will compute in this new spatial era.
Indeed. And the source material really does capture this duality beautifully, doesn't it? The raw ambition in creating a functional, acceptable output device.
Right. paired with this pioneering effort to create a completely new input mechanism.
And it really reminds us that defining what constitutes a new frontier requires weighing these different factors. Is it the functional, immediate, incredibly difficult to engineer output system?
Or is it the revolutionary, potentially long-term paradigm-shifting input mechanism? It really forces you to consider what constitutes the more significant historical advance. Both components are clearly necessary right now, but their contribution to the future of computing, well, they reside in fundamentally different domains.